this is the final part of this quite long introduction to empirical methods in software engineering, but it was quite long and quite verbose, I admit, but this is to give you first immersion in which are the concept, the terminology, the ambiguity also in the terminology that you will encounter in this research. And I think that it gives you enough information and enough concepts to better understand the different strategies that you will learn, because I may have taught you like controlled experiments, but you need to see before what is that is not the entire word, of course, of empirical methods in software engineering. And so I wanted to, in these previous lectures, to give you an idea of how large is the scope of this field. Okay, this is a presentation basically about a paper that was published by Stoll and Fitzgerald, was published in 2018, and is the ABC of software engineering research. Basically, is a taxonomy and survey of the different strategies that I use for software engineering research. Last time we spoke about data collection, so one of the building block of a strategy. Now you saw that data collection is part of building a theory. Here you will see the strategies that can be used to build this theory. Okay. First of all, why they started with this research? Because looking back at the history of empirical software engineering, there was no universally accepted taxonomy for the research method. So some paper, for example, this paper from Glass was distinguishing between action research, conceptual analysis, case study, data analysis, field experiment, field study, meta-analysis, literature review, protocol analysis. So a very long list, simulation, a very long list, while other studies, for example, Joberg, the third study, controlled experiments, surveys, case studies, and action research. So there were different names and also different meanings given to these concepts. There was a need to create some order, and at the same time a need to not to like let's say deny the truth of the previous work. So instead of speaking about methods in this taxonomy, we are speaking about strategies, and strategies can use specific methods. So you somehow hide all the ambiguity in these names in the methods that I used, and you simply call the new things, the new classes strategies. But it is a good comprehensive taxonomy. Okay, so we like to stick to it, and we like to speak about our methods in relation to the strategies that I will list. First of all, why a unifying framework? Because there wasn't a unifying framework, and everyone was using a different terminology. Okay, and this unifying framework is using three main concepts. Okay, is ABC because there are these three main concepts are actors, behavior, and context. So a framework is what is a framework? Is a quite generic, general word that identifies somehow a model to explain some concepts. So a model of concepts and relationship. You could see it as a theory that describes, as an ontology somehow, a theory that describes the concept in a certain area. Okay, the basic elements, the building blocks of this theory, of this framework, are actors, behavior, and context. So the actors in here are both human and technical. So we are referring to software engineers, but also development artifacts, tools, techniques, prototypes, software system, everything that can be identified as an object or an actor. Okay. Behavior behavior of all actors, so system behavior, but also software engineering behavior, and context. So context, again, like we were speaking before, is the scope, is the place in which these actors actually show their behavior. And it includes industrial settings, organizations, software projects, development teams, software laboratory, classroom, meeting rooms. So all the things that surround and that allows us to describe the environment in which I want to measure the behavior of certain actors. Okay. One key thing is these three main dimensions that I am considering. These three building blocks are three dimensions, and they allow me to position my research strategy. But it is important to notice that optimizing any study to achieve generalizability over actors, so to cover as many actors as possible. At the same time, be able to precisely measure their behavior and considering a realistic context, so close all the actors possible, very precise in measuring their behavior and considering a realistic context closer to reality, is not possible. Okay, it's not possible because we cannot maximize all these elements that are conflicting somehow. Why? The intuition is simple. In the distinction between a field study and an experiment, what is the main difference? Is that in an experiment, I am in a lab, so it's totally not realistic context, but I am able to measure very precisely some behavior. In a realistic context, so in a field study, another type of study, I can I have realism, but being precise is very difficult because it is very difficult. Like, for example, in the field study that I was giving, that I was presenting before, like we were using words for our constructs. We weren't measuring. We weren't so precise in measuring our constructs. Okay, and at the same time, generalizability over actors is very low because I'm considering a very specific company. Okay, you have to consider that performing basically something that is able to cover as many actors as possible, like a survey, for example, and at the same time measuring the behavior in an exact way, like an experiment, and considering a realistic context, like a field study, is not possible. Okay, so depending on what you want to on what you consider more relevant, you consider a different research strategy. Okay, there are other two dimensions that we want to consider in this framework, and then I will show you the framework, and are obtrusiveness and generalizability. Okay, obtrusiveness indicates to what extent does a researcher intrude in the research settings or simply make observation in an unobtrusive way. So basically, it means how much control do I have on the empirical settings. In the case of an experiment is more obtrusive in the sense that I am constraining, I am making modification to the reality. Okay, to control the behavior of the actors. At the same time, one research like a field study is less obtrusive because I'm not interfering, I'm not transforming the reality for my research. I'm studying the reality directly. And the other dimension is generalizability. Generalizability means to which extent the research findings are generalizable. Again, how much of the scope of interest is covered given the current scope of validity. This is the concept that we already met before, but is used in this framework to represent to position the different research strategies. This is the ABC framework from a higher perspective. Let's take some time look at the diagram, and then we will see the methods. We have 2 dimensions that are the ones of obtrusiveness and generalizability. And for more obtrusive methods like experiment, and we have precise characterization of we use them when the precise characterization of behavior is relevant, like, for example, experiments. Okay, cases that are less general and less obtrusive, I use them when a specific characterization of the context is relevant. So the field study, in which I want really to understand the things from the point of view of a specific context. Okay, if generalizability over actors is irrelevant, I will use strategies that are positioned in this other corner. Okay, this is as from this representation, you just have to remember that depending of what is relevant for you, either behavior, context, or generalizability over actors, you choose the specific methods. If you want to be precise on the behavior, you choose a method that is upper in the diagram. If you want, in the diagram that you will see in the next slide. Okay, if you want to have a more characterization of the context, you need to choose some method that is on the right side of the diagram. Instead, if you want generalizability over actors, you will choose the methods that are closer to the bottom left corner. Okay, remember always that behavior can be related to both people and software, because actors can be people or software. So I will find here both surveys, but also I will find here, I mean, in the corner about generalizability over actors, I will find both methods that generalize over software systems and generalize over developers. Okay, let's see the methods. We have 4 quadrants. Okay, that identify. Here is a more detailed representation of the diagrams that I gave before. But as you can see, you have the ABC elements clearly positioned here, but together with more information. Okay, the name of the strategies and the type of settings. Okay, let's look first at the settings. So we have a natural settings, the one of the field study, contrived settings, the one of the experiment, neutral setting, the one of surveys, sample studies, and non-empirical settings, format theory and computer simulation. So these are 4 different possibilities for the settings. Okay, for the settings that I consider. To remember this, there are some metaphors that you can consider. Field studies are similar to the jungle. Okay, studying in the wild. Okay, in the jungle, you don't control the jungle. Field experiments are more similar to a natural reserve. So I have some freedom, but at the same time I have some control. Experimental simulations are similar to the flight simulator. So I simulate reality. I try to simulate as much as possible a natural setting, but still is simulated. Okay, it's not the reality. In vitro experiments are the paradigm for laboratory experiments. So while in vitro experiments can be experiments that don't involve humans, for example, laboratory experiments in software engineering very frequently will involve human, but is a contrived setting, is an artificial one. Okay, while the flight simulator is closer somehow to the reality, try to mimic the reality. In the in vitro experiment, I isolate some variables from the reality in a very, very clear way to identify and measure actors' behavior. Then I have the judgment studies that are similar to the concept of courtroom. So I have several people deciding what is right and what is wrong, basically. And sample studies, the paradigm, the metaphor is the referendum. is basically surveys. So having information from different actors. And finally, non-empirical settings. I have the mathematical model and the forecasting system. Mathematical model is a metaphor for a formal theory. Okay, I deduce a theory that is not derived from empirical verification, but from literature, for example. Okay, and computer simulation is more similar to a forecasting system. Okay, is similar to the forecasting system, for example, for the weather, okay, or in which I am not basically, it is different from the experimental simulation, because in here I try to use the system as a representation of reality, but I don't have, for example, people there, or I don't have actors there. I do. We will see an example later on, but I do a model, a mathematical model of the reality, and I perform simulation through some stimuli, but I'm not using actual realistic actors, okay? Actual actors, ecco, actual actors. So let's start from the natural settings. Field studies. Field studies, I will always start in here with an example, and then I will list the characteristics. Field study is, in this example of field study, they wanted to investigate the impact of distributed teams, so teams located in different geographical areas, in software development. So is it better to have the people all together in the same building, or having them in different parts of the world? The setting was natural, and the author of the study, the first author, spent 7 months on site at one of the organizations. And he studied the documents, he made some observation and some interviews. So he used multiple data collection methods and identified 4 problems and 8 specific challenges. So the idea is that you have a reality, you go in a place, you stay there for a certain amount of time, and you collect the data in different ways. You see that this data collection method, they both mix, again, people intensive and not people intensive techniques, okay? Because document study, you don't need to involve the people, but while interviews, there is a high involvement of the people, so they're quite demanding for the people. So you mix the different methods of data collection, but the overall strategy is field study, okay? Field study, so this was an example, but in general, the main characteristic is the fact that the field study is natural. You don't want to disturb the realism of the environment, okay? There is a minimal intrusion, and is always just oriented to facilitate data collection. So, for example, an interview is an intrusion, okay, in some way, but at the same time, it allows you to find some explanation for the things that you may observe in the actual setting. Mainly, you do field study for exploratory purposes, okay, to understand what's going on, to better understand a certain environment, okay, not for doing precise measurements and predictions, okay. And the typical methods that you use are case studies. We will see this is another term that is somewhat everywhere, and it may mean several things, but basically a case study is rigorous, let's say not so rigorous, but a research methodology applied when you do any study in companies, okay? Ethnography, observational study, this can be considered all names of research methods that have some overlapping one with the other, but think that you are generally using qualitative data collection methods, so interviews, field notes from observation, archival document. You could include also quantitative data if they are needed for your research goal, for example, about costs, about time. but you may need to ask the company also for that. It is not always easy. One thing that is not mentioned so frequently is that when you do field studies, we will speak about it when we look better into qualitative studies. But when you do field study, you have always to consider that many of the things that you find in a company, you may not be allowed to disclose. So this is a big problem that frequently PhD students encounter when they get in contact with a company and they do a study. Maybe they even contribute to the company, but then they cannot publish their work. There are problems in the thesis, and maybe they are PhD students and they need to publish. Okay, so you need to clarify always from the beginning what you can publish and what you cannot, so that what you cannot publish, you observe, you try to get the information, but you tend to focus on what you can make public, okay? Because otherwise the science and the field does not advance, because you may know it, as we taught in some lectures, but the other people don't know. So it is important that you make it explicit. The main limitation is the lack of generalizability. So you study a company, is not generalizable. You don't have control over the events, and you don't have so much precision in the measurement, also because you're using mostly qualitative data. In essence, the idea is that you don't manipulate the reality, and you are using a realistic settings for the specific system and context that you want to study. So you are focused on a specific context. It is not appropriate for investigating statistical relationship or manipulate variable, and it is not appropriate for findings that you want to hold for larger populations. So when do you need to use it? When you are in an exploratory phase, you don't want to intervene too much on the environment, on the settings, because you don't want to make assumptions beforehand, since you are still in exploratory phase. You don't want to manipulate the reality, okay? And you are willing to gather some abstract high-level information that may allow you later to define more detailed hypothesis and more detailed research question. But at this stage, you want just to understand what's going on. Okay, understand what's going on. Elicit concepts, elicit propositions that are quite high level. So the example that I gave you before was a field study. Okay, the example that I gave you in the previous hour. Second thing, still in natural settings, is the field experiment, the natural reserve. So I'm passing from the jungle to the natural reserve. The goal, in this case, the purpose for this example, as I told, I start from example, is to identify a cost-effective way to avoid software defects. So they wanted to understand which was the most cost-effective way. They considered this setting in which there was a company, and they introduced a researcher that was performing some collaboration in the company, using new real products, so the products of the company, to evaluate new approaches, so for avoiding software defects. So was developing basically new techniques within the company. The procedure was, we can call it improving case study. Here is called action research. Also, this is a term from the literature, but and it's frequently encountered. Basically, in our lecture, we will call them improving case study. Okay, a case study, so a study in a company that is aimed at improving the process. Okay, and you have a person, a researcher, that participates and contribute with this transformation, and at the same time measure the effect of this transformation. So you have a defect report. For example, the data that is collecting in this case are defects report, the time spent, usability issue, timeliness of the project, product sales. You see that in this case, compared to field studies, you already have some more detailed information. You are closer to measures, okay? And they found that certain techniques were beneficial while others were time consuming and did not avoid effects. So they were doing some an actual experiment. They were doing measures, but in a real environment. So many variables were not controlled. And you couldn't, for example, randomly sample subjects. You were in a specific company with specific software, with the specific characteristics, and you are introducing new approaches, and moreover, you are present there, and you bias unavoidably the research, okay? Still, it is valuable because it helps the company. So in this case, again, the setting is natural, it's pre-existing, but there is some level of intrusion because you are transforming, you are introducing some new element in the setting. In this case, you are experimenting with new technologies. Okay, the purpose is can be to investigate, evaluate, compare techniques. So there may be also a level of exploratory analysis, but is more advanced, of course, because in this case you want to to transform that reality. In a field study, you study it, let's say you analyze it. In this case, you improve it, you transform it. Typical methods and data are case study, quasi-experiment, action research, and again, action research is a synonym for improving case study. And you may use both qualitative and quantitative data. As I said, you may have a part that is more qualitative and more related to exploratory aspects, and one is more quantitative. And again, limited generalizability. And there are confounding factors. As I said, you are present there, you have a bias, you are participating to the environment, you are the environment is, of course, full of variables that you don't control, okay? So you cannot measure the behavior precisely. That's why in the diagram, field experiments are positioned on the right side. So very specific for a context, but generalization over actors is more limited. Okay. So this type of study is useful when you want to transform you want to transform a certain setting, and it can be potentially very costly. Okay. To set up and evaluate. And again, as I said before, results are not generalizable. Okay. So these are the two type of case study. Let's call them this way, in which you do either a field experiment or a field study, but still we are speaking about case studies. Okay. Also, experimental simulation may fit into case studies. Let's see an example. Here we are dealing with contrived settings. So what you've seen now is when I maximize the realism of the context. Okay. Now I maximize the precision of measurements of actors' behavior. Okay, in a contrived setting. This is an example. The purpose is to understand how developers perceive the testing team. So I have a company and I want to understand, do this developer like the testing team, or like they have some form of conflicts with them? Which are these conflicts? Okay. And the setting is contrived because in this experiment, because I've built a simulation environment in the company in which I defined previously the experimental stimuli. So I defined the software that has to be written by the developers and that checks to be performed by the testers. So they are doing a sort of role-playing activity in their company themselves. So I ask the software developers to develop a certain software according that is of course limited. It's not like the entire software is a sample, is similar to what you would do with a lab experiment, but in a specific research environment. So a specific software team and a specific testing team, specific development team and a specific testing team, okay? And I have defined the procedure, okay? What would be the procedure for developing the software and also the checks to be performed by the testers. So develop code, test the test, and give feedback during the meeting. And the researcher, in this case, observed the impressions, okay? And they found that there were several defensive reactions interesting by the developers. So typically the testing team is saying, hey, you made this mistake. And the developer, of course, reacts by providing justification, okay? So this is an example of an experimental simulation. It's like the flight simulator in the sense that I'm recreating the reality, but at the same time, as much as possible, but at the same time, it's not the reality, like in the natural reserve, okay? The setting is contrived, is in virtual, it's not the natural, it's not the realistic one, okay? The goal is to have a controlled setting that resembles the real world, so a concrete class of settings as closely as possible. And the methods are role-playing games, as I was saying, or simulation and management games. So this type of approaches in which you involve people in a role-playing activity, basically, like the one exemplified. And you collect data that can be related to qualitative and quantitative at the same time. For example, in the example meeting, you may have quantitative data related to the time people are speaking, or qualitative data related to the type of reactions that people may have. The inherent limitation is that, again, generalizability is reduced because the setting is designed for a specific type of settings. So I have the people from the company, and the realism is at the same time reduced because the setting is somewhat artificial. So these are similar to lab experiments, but quite context specific, okay? Just okay. And in essence, basically, here the characteristic is that the contrived settings simulate a specific class of real-world system and try to resemble reality, but is not reality, okay? Of course, it allows to observe a more natural behavior than lab experiments, okay? And but the measures are more precise than field experiments, but less precise than actual experiments, okay? And it is important to consider that the behavioral actors may reflect that they have in natural settings, because it may reflect the relationship that they have, but consequences for actors may lack realism, and this may affect their behavior. Indeed, like for example, you may have this meeting between developers and testers, but you may also have you may also not see all the possible aspects, because after this role-playing activity, there is no, for example, refactoring of the code. So they may have written errors in the code, and the testers complain, but then they are not forced actually to modify the code. So their reaction may be different from the one that they have in the reality, okay? Now let's see laboratory experiment. Give me so in vitro experiments. In this example, you want to investigate the hypothesis that a certain code inspection method A is more effective than another method B. Typical experiment, okay? The setting is contrived, so as we are dealing with contrived settings. as for the simulation case. And I use graduate students. So this is another subtle difference, and it's quite typical of software engineering experiments. When you have to deal with people and you want to do an experiment, there are very few cases in which you are sampling from a real community of developers. You often use graduate students as a proxy, okay? And of course, it's different. The experience is different, but they have demonstrated that many aspects that are of interest for empirical software engineering can be identified also with software engineering or computer science students instead of real developers. Okay. In this case, they measure the effect of the inspection methods and consider 4 variables, including fault detection rate. So they wanted to use this inspection. Inspection means that you read the code and you check for you don't run it, and you check for possible defects of the code by reviewing it. Okay, it's a form of quality assessment of the source code. Okay. And they consider also fault detection rate of the different methods. These methods are normally checklists. Okay, did I find this type of problem or not? How many of this problem did I find? So this is typically the strategy for inspection, to give you more information about the context. They found that inspection method A is more effective than inspection method B. Why? Because the fault detection rate is higher for a given specific document and well-defined contrived settings. So in this case, the key thing is that in laboratory experiments, I control all the measured variable. I have a full degree of control. Okay. I can measure with a very good precision the relationship between the variables. So if I use a certain method, I can measure what is the fault detection rate in a certain precise manner. If I use another method and I keep all the other variables fixed, I can measure the fault detection rate in a precise way, and I can compare the two methods in terms of fault detection capability. I can also, with the laboratory experiment, I can also establish the causality between variables, because if I isolate 2 variables and I see that in a certain moment variable A is introduced or is activated, and variable B is activated later on always, and there are no other confounding variables, I can see that I can establish that there is a form of causality between A and B. So A is causing B, because it always happen before B, and they always happen in the same occasions. Okay. Typical methods of data here is the randomized controlled experiment, and normally use quantitative data. Okay, the limitation is that it is artificial, so I focus on very specific variables, but I'm not representing the reality in which many variables interfere. For example, in the example of the 2 methods for inspection, for sure I will use some representative documents to be inspected. Okay, these are no, and these can be representative of reality, but they are not the reality. In the reality, I may have longer documents, much more variability, and an additional element, I'm using students and not experts. So there are some inherent limitations that are related to the fact that the setting is artificial. Okay, also the time that I can dedicate in a field study is different from the one that I can dedicate in an experiment. Okay, and these are oriented for studying the essence, so for studying very precise thing. And the idea is that we optimize internal validity at the cost of external validity. Okay, we are oriented to be sure that the internal validity aspects are covered. Okay, laboratory experiments that are in these slides. You see the essence again. So control settings, precise measurement, and these type of studies are more artificial than experimental simulation. Okay, while in experimental simulation you try to mimic a real environment, a real context somehow, in a laboratory experiment you try to abstract from specific context. Okay, this is in vitro experiment, and now let's look at the methods that are related to a neutral setting. So I'm not constraining, I'm not in the natural one, but I am in a neutral setting. Let's see some example that is easier. First one is judgment studies that are, as I said, similar to courtrooms. For example, I want to evaluate 12 practices based on the feedback of team managers. So 12 software development practices, different software development practice, and I have the feedback by people coming from different companies. Okay, the setting is neutral because I consider a meeting room. I call my subjects and allow them to sit around the table and discuss. Okay, I take 10 managers from 7 different companies, and I select them on purpose. So I select them based on their experience of the different practices, okay? Based on their interest, based on their expertise. So they are champions somehow. They are representative of the people who know about a certain topic, okay? And the output is a conceptual framework of defect and benefits for the 12 practices. Okay, so I select in this case the people that do the judgment. The setting is neutral, so we want to nullify the context. We are speaking about general cases, so it is important that I selected people from different companies. Okay, because I want to take as more context. I want to cover as more context as possible. Okay, I want to generalize independently of the context. Okay. In relation the reaction, so can be how do you say, the reaction of the people can be related to some stimulus. Okay, I might have some specific questions, so I don't leave them free to discuss. It can be guided by some specific question, or I can involve them in using a specific methodology and assessing whether which is their judgment. Okay. In this case, the goal is to elicit information from subjects for subjects that are knowledgeable about a certain topic. When do I use this? I use this when a certain topic is very complicated and is broad, and I cannot find a large amount of people that can answer my questions. For example, if I have to study the effectiveness of, for example, formal methods that are mathematically based techniques to model and develop software, okay? People who are experts in industrial application of these methods are not so many, okay? And I have to select precisely, because if I do a questionnaire, I can gather some relevant information, but I don't go deep into the technicalities and the aspect that may be relevant to understand benefits and challenges. Okay, so you do this study when the knowledge required is extensive and few people know it. Typical methods are Delphi studies. Delphi studies is basically similar to brainstorming, but it's not similar to brainstorming. Let's say you have different subjects, they give a judgment, and then independently, so for example, you decide this method, how good it is, and in a paper, the different experts, they evaluate, and then they share with the other their evaluation, and the other can discuss, can give feedback on this evaluation. Okay, there are multiple stages to reach a form of agreement between experts. Okay, multiple stages of personal and collective judgment. You can use also focus group, brainstorming, etc. Okay, and normally you collect qualitative data. You can also collect quantitative data, but it's more unlikely, let's say. Responses are general, so they are not related to specific context. Okay, they are less generalizable also than surveys, because you don't do a representative sampling. You just select 10 people, for example. So you're not doing random sampling. You are selecting specific people, and you don't have like an extensive number of answers, and you cannot do frequency analysis. Okay. At the same time, you have less control and precision than the lab experiments. Okay, because but also your goal is mostly not quantitative, is mostly qualitative, and so it is a limitation, but you wouldn't apply a judgment study in a case in which control and precision is strictly relevant. Here you want to hear the opinion. Okay. This facilitates the study of facilitates the elimination, basically the neutralization of the context, and compared to surveys, you can ask very complex questions, have deep interactions, okay, and you can elicit more information. So the main issue is that the absence of a neutral setting, as we were saying before, there is a problem. While you tend to be more general, of course, and you ask general questions, you are not referring and you are not observing the phenomena. You are just asking impressions. Okay, this is a relevant thing. Sample studies. So sample studies are also in a neutral setting, and this is a in this example, you have a web-based questionnaire to investigate the state of practice of requirements engineering in industry. They had 22 questions. They got participants from internet, and they got this almost 200 responses from a population of 1,500. So they asked many people, but they received these answers. And they had some findings about the different type of life cycle model, the requirements engineering techniques that they were using. So some statistical information. They made a survey. Okay. In this case, again, the setting is neutral, and but the issue is that the researcher has to deal with whatever data is collected. So you cannot ask clarification. You cannot ask clarification to the answer. So you have to be very, very precise in your questions. And I will give you a lecture actually on building surveys. Filling a survey is normally quite easy, but building a survey that is easy to fill by many people is extremely difficult, especially in a so diverse environment like software engineering. Okay. The purpose is usually to study the distribution of some characteristics, so evaluating some frequency about the opinion on usage or the actual practice of usage of a certain technique, for example. And the methods depend, of course, on the type of actor that you consider. If your actor is a human, you normally do a survey, which is a questionnaire. If the actor is software, you use software repository mining. So mining software repositories, the techniques that I was explaining you last time. Okay, and if we have time, we will do a lecture on that. Normally, you use quantitative data, okay, but you can have also qualitative one. But these sample studies are oriented for mostly frequencies, okay, because it's easier because of course a questionnaire, intuitively a questionnaire in which you have just check boxes instead of free text boxes is easier to analyze in terms of frequency. Okay, because the free text boxes has to be analyzed like interviews, but you don't have the possibility to ask clarifications. Okay, limitation is that you are limited to a set of questions, so you cannot ask too many things. So you gather knowledge about a certain area, a limited area, let's say, and you don't have the interaction. This is very important. I mentioned again, you cannot clarify. Okay, and you cannot, you cannot manipulate variable, but you only correlate them. Okay. The essence is that the sample studies allow the maximum potential to generalize the findings to a wider population. So I reach more people, and so my findings may be valid for a larger population with respect to what I find with a case study, and is unobtrusive. So I don't transform the setting. Okay. The evaluation consideration is that questions tend to be simple and there's no complex interaction, and you may ask questions about real context, but they are just opinion. Okay, again, like the judgment studies, you have no reference to a realistic context. Formal theory is, these are the final types. Formal theory is a way of basically building the analogous of mathematical models, but in software engineering. So in this example, we have a study in which the authors wanted to develop an understanding of the role of creativity in requirements engineering. RE is requirements engineering. Okay, so what is the impact of creativity in identifying new requirements for new system? Intuitively, this is relevant, for example, because if without creativity, the iPhone couldn't be invented. Okay, or the iPad, or the all the things that all the technical thing, all the new software that you find, market software, is based on some stimulus that come, yes, from customers, but mostly from the creativity of some people that are able to observe the reality and come out with new smart solutions. Okay, this is I open a parenthesis in this because software, when we speak, for example, about requirements elicitation, we speak about an activity of interacting with a customer, for example, the hospital, that is asking me to develop some software. So creativity here, I have some creativity, but it's limited somehow because I have to do what he's asking. Okay. On the other hand, if I am developing a new creature, a new software for the market, okay, I can invent. I have to resort a lot on creativity because my main goal is to introduce a product that is new. So no one, not even the users, the potential user, have thought about that product. So creativity is key. Okay, and in the middle there are different shades, of course, because you may have a previously developed software for the market, like, I don't know, Microsoft Windows, for example, and you may have people that that give you feedback on the usage of the product, both direct feedback with some user studies, or indirect feedback. For example, when it crashes, you send the crashing information to the developers. Okay, and so you can improve your software. So let's close the parentheses. But this is a study for understanding the role of creativity in requirements engineering. So in this case, zero empirical observation, no observation, but I do I research from the literature. Okay, I derive this framework by checking creativity literature and requirements engineering creativity literature. So I derive a formal theory by doing a systematic literature review, basically. And the output is a theoretical framework that offers the researcher the basis to incorporate creativity in the requirements engineering process. Okay, this is never this formal theory is not tested empirically. So somewhat you could see it as a non-empirical study. At the same time, you are dealing with literature. So you are dealing with something that exists in the world and that can be a guide for further empirical studies, because once you have a theory, you can see if it works. So you can try to follow this theory and see if it actually allows to improve your software development process, for example. So the setting is non-empirical, as I was saying. The setting is an office or a library. And the goal normally is to create a framework, a conceptualization, and identify relations and explanation, relation among concept and explanation for a wide range of contexts. So formal theory in software engineering is usually a framework that tries to cover as many cases as possible. That's why you also resort from available literature. For example, you may have found formal theory is related also to that process of abduction that I was speaking about. Okay, for example, I have found several studies that say a certain thing, that say that, for example, the involvement of user in the first stages of system development, so in requirements, in the requirements phase, is positive. And I need to check in which fields these studies have been applied, so I can build, I can group the conclusion of these studies and build a higher level theory, abduct a theory. So in this case, the abduction is related to the creation of a higher level theory that merges and encompasses different theories that have been developed through empirical research. Okay. Still, the theory needs to be verified. Okay, because I'm doing a step forward. I'm abstracting. I'm introducing new content. Okay. The problem is that there's no realism, and I'm not manipulating variable measurement. So there are several limitations. Of course, formal theory is always a stage of empirical research, but a very important one, because once you have a formal theory that is solid, you can refer to it to predict and to do everything that you need in your software process. This is the most generic thing. So for covering all the classes of populations, is the most general, tend to generalize, maximum generalization over actors. And it may be useful, as I was saying, for future empirical studies. And finally, we have computer simulations. Computer simulations are similar to formal theory and at the same time are similar to field study. In which sense? In the sense that let's see this example first. The example is to investigate the bottlenecks or problems and overload in the testing processes of a company, okay, of a software company. It was implemented a discrete event simulator. So they tried to introduce some artificial variables, and they built a computer program that was simulating the fundamental variables and fundamental interactions in a real process. Okay, somewhat you could think about a Petri net, if you have confidence with that, or a form of a computerized diagram in which you can evaluate how the process goes and which are the bottlenecks. Of course, this is not the reality, but is a simulation scenario that mimics the reality, considering what me as a researcher I consider relevant. Okay, I do some form of abstraction. I operationalize somewhat the theory in a computer system. They saw by running several experimentation with this simulator that to avoid congestion in testing, they need to increase the number of staff and increase the number of interactions with the development team. Of course, if I didn't consider some very relevant variable, this would not be noticed in my simulation environment. So it is important that it's very close to the real environment. But I didn't experiment with real people. I didn't involve people at all. So it is a way for doing estimation without requiring strong people intervention. The setting is non-empirical, in silico, because it's in a computer, and everything is specified in the simulation. The fact that I'm using a model, so I'm basically representing variables and relationship in an artificial simplified model, it allows me to evaluate many scenarios, so multiple scenarios, and that cannot be tested with the same time, within the same time frame and effort in the reality. Okay, and normally you do this based on previous empirical studies, and you collect normally quantitative data. But consider that no empirical data is gathered. You are gathering data that are estimates of what is the reality. The generalizability is lower than a formal theory, for example, because in my simulation I tend to represent a specific class of systems. So I want to understand what are the peculiarities of a certain company. Okay. So in essence, the key thing here is being able to simulate many scenarios, and the main issue is that the actual empirical behavior is not observed. And to build these type of models is not so easy, because in software engineering, theories are limited. At the same time, I have little support for building models. At the same time, the contexts are all different, and they have many different variables. So it's difficult actually to create a model, a realistic model. Okay, so that can be simulated. So these methods are not so frequent. Here you see which methods are more frequent in software engineering and which methods are less frequent. So in vitro experiments are very frequent. Okay, same time field experiment and field study are frequent. So there are case studies, experiment case studies. Surveys are quite frequent, not as frequent as in vitro experiment and as case studies, but quite frequent. Surveys, and especially mining software repositories now, so referendum, sample studies are frequent. Conceptualization, mathematical model, if we include systematic literature reviews and systematic mapping studies, so studies that gather literature on a certain topic and try to frame conceptualization of this literature, these are frequent in software engineering. Okay, if you are dealing with the more formal theory in the sense of mathematical models of behavior that can be afterwards computer simulated, like a forecasting system, these are not frequent at all. Okay, same thing for the flight field simulator, not frequent at all, because you normally, if you have access to the natural setting, you normally use a typical case study with a field experiment. Okay. Because in a field experiment, you can actually help the people. You can help the people in the company. With a experimental simulation, the one that profits is just the researcher. So it's very hard that the company allows you to perform an experimental simulation. The courtroom are also quite rare, because I would say that it is hard to find valid output, because you are really relating with experts only, and there are not so many guidelines for performing this type of studies. So they are not so frequent in software engineering. We tend to rely more on, and it is derived also historically, I think, because before field studies and field experiments were just experience reports, let's say. So there was a lot of opinion of the researcher. Now the research is heading towards a more objective, although slightly biased, research approach. Judgment studies are inherently opinion, okay, inherently opinion and of a limited number of people. So they are not so frequent also because they are considered more flawed. Although in some cases you have no way but to use a judgment study because, as I said before, few people know about a certain topic, for example, that is anyway relevant for the software engineering field. So this is an overview of the methods. We will see, in our case, we will see in vitro experiments, so laboratory experiment, okay? We will see case studies in the form of field experiments and field studies. And in particular, for field studies, we will see qualitative, we will refer to field studies when we speak about qualitative research methods, because qualitative research methods very frequently go together with these field studies that are more exploratory. Okay, we will see mathematical modeling in the sense that we will see systematic literature reviews, and we will see sample studies because both from for sure from the point of view of people, so with surveys, and from the point of view from the point of view of people, but also from the point of view of software as actors. So with mining software repositories, if we have sufficient time for this content. So to conclude this very long introduction, I would like to give you just a few information, a few hints, a few reflections that are taken from Daniel Mendes, who is a colleague. And I invite you also to look at his slide. I took inspiration from his slide also for the link is there in the slide for the part on building theories in software engineering. So if you want to know more, especially about concepts, philosophical contexts such as reductionism, constructivist, and positivist approaches, and all these philosophical terms, you can refer and have an even larger view of the theory building. You can refer to his own slides, okay, that are public. The thing that you should remember and that we can consider as commandments of software engineering is that of empirical software engineering is that there is no such thing as an absolute or universal truth. So truth is always relative, okay? Everything I apply one of the methodology, as I said, I lose some information either on the behavior, on the actor, or on the context. So there is no way in empirical studies to find a universal truth, okay? The value of a scientific theory that is derived through one of these strategies depends on the ability to stand criticism by the research community. So peers have to evaluate to what extent you are convincing, okay? To what extent your study is convincing, okay? The contribution to the body of knowledge, so how much you are actually contributing in terms of existing evidence. Does your contribution actually say something new and sufficiently different from what was told before, or is sufficiently confirming to a certain degree what was intuitively shown before, for example? And ability to solve a problem. So ability to solve the problem is fundamental. So the value is related to how much also it is useful, your research, your theory is useful. Okay, this is, as I said before, I want to repeat it. Theory building is a long endeavor. As I said, as I've shown, there may be a step, inductive step, then afterwards a deductive step, followed by other deductive steps. Okay, you may have different iterations before covering the scope of interest of your theory. Okay, and these iterations are also within the study themselves. As I said, when we were speaking about research questions some time ago, your research questions become stable just at the end of the research, okay? Because the data will show you something new always, and you will have to iterate even in your own research. So iteration means that you have iteration between different stages, from exploratory to explanatory. But at the same time, you have also iteration within your own research to change, to make linear, to show as linear something that actually was developed through different iteration. And again, it is important to consider the acceptance by peer. So research communities are key in here for both acceptance and criticism of your own research. Not just evidence, but also evidence that can be communicated, and it is argued in a clear way, so that other peers, other people that are competent in the field, can judge. Okay. The other commandments somehow are: be skeptical and open at the same time. Of course, this is also key. Do not consider that something that is some statement that you find in the book, or that I communicate to you is true and is true forever. Okay, criticize it, because things change, and both in the rigor in which research is performed, and both in the software engineering reality. The way we were building software 10 years ago, 20 years ago, is not the same way that we are approaching the software problem today. Okay, and be also open at the same time, skeptical, but also open to the new arguments that are expressed, because this is not a process in which we are building theories and it is like a pyramid that remains there. Okay, theories are transformed with time, because theories try to represent a reality that is ever changing. Okay. Fundamental to consider strengths of limitation of the single research strategies that we listed before. So again, no silver bullet, no strategy that can optimize for the different elements. And consider the validity, analyze always the validity of your study, and be self-aware also of the bias that you may introduce in your research. For example, here I can give you an anecdotal aspect. It's not related to software engineering, but is related to the use of LSD in is related to the usage of LSD to cure some mental disorders. Okay, and also to enhance the capability of the people to have some form of mystical experience. These people that were doing experiments with this product, hallucinogen product, basically they were explaining before doing the test with the people. They spent like 1 hour or 2 with them, explaining them what would be the trip like. Okay, and they asking somehow questions to them that were already driving them towards a certain type of mystical experience. So the experimenter was actually oriented to have a good experiment, a sound experiment with randomized trials, people selected randomly, but at the same time, the way that he was training the people for the experience was biasing them towards the mystical experience. So they were speaking already about mystical aspects 1 hour before. And of course, this had an influence on the way they experienced the actual trip with the LSD. Okay, if they were speaking about, for example, tragic aspects of the usage of the drug, the experience would have been probably a bad trip, or something completely different. Okay, I'm giving you this as an example because it is showing the good faith of the researcher in creating, in demonstrating that something is useful. Because for these people, using this drug was actually seen as a new medicine for the people. Okay, but at the same time, they wanted to they meant good. They wanted to do the experiment in a good way, but at the same time, they were introducing some bias. Okay. Finally, appreciate the value of all research process and methods. You've seen a variety, very large variety. New results. So also if some theory that is developed it doesn't work. So if you happen to review a paper or to read about an experiment that failed, don't criticize that much, because knowing that something doesn't work is knowing. Okay. And appreciate replication studies. So if someone did the same thing like another one, this still has value. Okay, because progress and knowledge come through repetition. And one key quality of research was testability. If I can replicate a study, it means that it's testable. And if it's testable, it means that if I reproduce the same results, these reinforce a lot the study, because it takes away a lot of the possible bias that may be introduced, and a lot of confounding variables that may be introduced in the earlier studies. So replication studies are very important. And again, be an active part of something bigger. In your studies, if you go ahead with studying these topics, you will be able to cover in your career just a few steps of a certain theory, and just contribute to some bricks of the whole, some elements of the whole knowledge. But you will need to rely on other people, and it is important that you clearly communicate your results. Okay.